Jai Mahakal and welcome to Next.js Yatra. I'm so glad you are here. So let's begin our great learning path. So in this particular lecture, we are going to perform the LLD of the problem statement. What is an LLD? LLD is a low-level design, and there are various stages of system designs. One is LLD, another is HLD. HLD primarily deals with various types of systems interacting with each other. Since our hosting solution and interactions are already handled by Vercel, and there is very negligible infra, like high level infra that we require, we are only focusing right now on the LLD part of the solution. So what is a LLD? LLD is stands for low level design, and it primarily focuses on the component architecture or the code level architecture of the entire application. And that is what we will be focusing in this particular course. Also, not to mention that we will also be covering just a minor parts of like high level infra, like what are the services we are using and what are the clusters and everything. That thing I think would come under when we deploy our application and other stuffs. But right now, what are the things we are focusing on? So if you see on the screen, we have this. If you have already seen the previous videos, I have already shown what project we are going to make and how it will look like. So this particular is a wireframe of that particular application only. On the top you see the nav bar, on the left you can see list of all the boards, and these are vertical columns representing the status of the ticket, and inside each column we have various square boxes which are ticket itself. So I have marked each and every portion of the screen, and you can see yellow lines taking you to the boxes. So also make sure that we are keeping the standards up to the industry. So there is no compromise on that. We are sure on that part. And what I wanted to say that doing a system design is not just making boxes. It is much more than that. Okay, that we'll see in this. Like, although the board looks very clean, it is not very messy, not bombarded with lot of information. You can see the boxes are very square, like very small and to the point. Okay, I wanted to keep things very relative, okay, very to the point, crisp and clear, no BS. Okay, if you don't know BS, you can google that out. So that was the main agenda. Okay, I wanted to keep things very clear and the things I perceive as a software engineer. Okay, that is my motive over here. So when you are given a problem statement in a company or in an industry, what is the first thing you do? You go to the Figma designs. Okay, Figma designs are basically the wireframes. Okay, that graph, the UX designer, they provide this is the nav bar, this is how it will look, these are the components. If this is the home page, what are the various parts of the home page? So that particular thing, my friend, is the Figma design. So since we don't have Figma, so what I have done is, and even in interviews you won't be having Figmas. Okay, so it is a good idea just to go to Miro board and grab the shapes and start making the basic outlet of the application. Most of the applications are basically square boxes here and there. Okay, so what is the first thing as an engineer? So let's say, given I am in XYZ company, in a multinational big company, let's say I am in Google. Okay, let's say I'm in Google and I am leading this project. I have to make a JIRA board clone for Google. And so as a team lead, what I have to think about, okay, what is the first thing that should come in my mind? I have to think on that. So as an engineer, I will go to Figma designs. Okay, I will see, this is the nav bar, this is a list of boards, and this is the columns, these are the tickets. Okay, that I have a rough image of the whole application in my mind. Now what I'll do is I'll copy that Figma on this board. Okay, I'll copy this Figma on this board, and I'll start thinking how various components will behave in a Next.js app, in an application. I have not yet decided whether I will be using Next.js, whether I'll use a Create React app or White, or whether I'll use any other, whether I'll use Angular or so what. So let's start from the very beginning. Okay, very beginning. So in the very beginning, you can see that we have this framework as Next.js, DB type relational, DB is Postgres, and hosting Vercel. So why I have chosen these things? Okay, so since this is a new project, Okay, so this is a new project, then using any legacy framework would not make sense. Okay, so given given my project has a lot of budget in the company, okay, whenever a new feature comes, company allocates some budget to that feature. Okay, इसमें these many engineers will work, these many hours or these many months they'll take. This is a cost to the company. Okay, this is already defined. I assume that given Google is a very big company. They have very good. They can invest a good amount of money in this project. So it is a better choice to use Next.js 14 because Next.js 14 comes. I know I haven't taught you much about Next.js 14 yet. You probably might have idea what Next.js 14 framework is, but you don't know in depth because that is what we are going to cover right now. So why Next.js 14? Because Next.js 14 is the latest tech stack. Even Meta recommends using Next.js for the new projects. Okay, if you have a legacy project, then it might be on some older versions of Angular, or it might be Vite, it might be CRA. So that is something we have a leverage on. Okay, we have the leverage to use the latest tech stack. And my friend, there are many use cases where companies switched to Next.js 14 and they have costed them a lot of significant performance improvements. Okay, so they have improved a lot in performance. So for that you can like check my posts on LinkedIn. I usually post case studies of front-end system design, and there was one case study where how one company like shifted to Next.js and it improved their performance like anything. Okay, so keeping that thing in mind, I have the leverage to use the latest tech stack. So I'll use Next.js 14 because it comes with built-in performance optimizations. So my app is going to be very fast, very spontaneous, and it would be super amazing application. So I'm using Next.js 14. Okay, we are not, and there's a added advantage of Next.js 14 that we don't require any separate backend for it. Backend, this is a full stack application, so it would be a single repository. Okay, now what is the DB type? So DB type so how you think of DB type? Okay, this is a great part because based on a database type, the whole application is going to depend upon its scale. Okay, so if you don't know, there are two types of databases. Primarily, one is SQL database and one is NoSQL database. And please keep in mind, friend, do keep a notebook and a pen ready every time you watch my lectures. Okay, I don't want to emphasize, but you have to keep notes ready because that is how you learn. Even I myself, till this date, I prefer pen and copy. Okay, I have this. You can have this. I have this pen and I have this notebook with me. Okay, so it is very important to keep these things with you. Okay, now coming back what I was saying. Yeah, so database type, there are two types of database types. One is your relational and non-relational database. Okay, so how we will decide whether I have to choose NoSQL or whether I have to choose SQL? So before choosing, I have to know, okay, what is SQL, what is NoSQL? So SQL data is a database where the entities are heavily related to each other. Okay, when in any given problem statement you find a very deep connection, a deep relation between various features, then my friend, SQL is the best DB type for you. But if you see the application is very fuzzy, the application has no definite a definite relation between the features, and it is abruptly like going here and there. So for that cases, NoSQL is good because NoSQL fits for unrelational databases as well. It works for relational database, but it is also working for non-relational database. So that was the two basic differences between the database types. There is another difference that the SQL databases are vertically scalable. So vertically scalable means that suppose you have hosted your application on a single server. This square box is a single server, and this app, let's say I have to scale this application, so I don't need additional servers. Okay, I don't need multiple boxes. If I just increase the RAM, the CPU memory of the existing server, then my application is going to scale vertically. This is vertical scaling. What is horizontal scaling for NoSQL? So let's say you have a NoSQL server. Now if I want to scale this for many countries, many regions, okay, many planets, so what I have to do is I need additional servers. I have one server for this, one server, let's say one server for India, one server for US, one server for UK, okay, whatsoever. So my infra cost is very high. This is horizontal scaling. What do you mean by horizontal? Like you have one server, then you have one another identical server. Now your traffic is going to get split between these two servers. So one server is for India, so all the requests will be handled by server A for India, and for US server B will handle. So this is horizontal scaling. So if you find relation between the entities, and if you see that your infra cost can be same, go for SQL, SQL database. And for NoSQL, if you see there is no definite relationship and the budget is no deciding factor for you, then go for NoSQL. So for our case, for our application, okay, how did I came up whether I have to choose a relational data type? And trust me, it is a very important question in interviews as well. Like before beginning, interviewer will ask that whether you should choose NoSQL or SQL. So that is a place where you have to think a lot. So I have made it easy for you. How? See, so I can see a very higher entity, that is a board. Inside boards, there are various columns, okay, and inside various columns I have many tickets. So I have formed a simple hierarchy: board columns, ticket. That is simple. So I can see that there is a definite relationship. Grandparent, parent, and child relationship is formed very easily. Then why do I need to bother about NoSQL? Okay. So I am able to clearly establish a relation. Okay, this is the relation between all the entities. Then definitely I'll use NoSQL. So you can back this point, okay, by stating that, okay, I can see a clear relationship between the entities, and that is why I have decided to use relational database. And if we are using Next.js framework and if you are using relational database, then Next.js is having a great support for Postgres DB. Okay, so we have chosen Postgres DB, and since we are choosing Next.js, our hosting can be very simplified if you use the Vercel hosting solutions. Okay, so we have decided the initial infra. Okay, and trust me, these little things come inside HLD as well. Okay, this could have been a part of HLD, but we are not diving deep very into it, because this hosting part, Vercel is doing all the stuff for us. It is maintaining multiple instances of servers and other stuff, so we really don't have to worry about that. But if you like in future, I'll also explain how we can use AWS for hosting our Next.js applications, because sometimes Vercel cost a lot. Okay, what the pricing of Vercel is really very high, and you can cut those costs by using demand based approach. Okay, demand based pricing on the AWS. So that is something for future, definitely in this course only. But right now, to keep things very simple, I don't want to overcomplicate things by diving into DevOps and other stuff. So I'm using Vercel hosting solutions. So I have backed my points, 4 points, why and how. Okay. So think like an engineer. That is the whole purpose of this Next.js Yatra. So if we come back, so Figma, I got the Figma from the designer, and here I can see I have various components, navbar, list of boards, then I have this board columns, then tickets, and how I am going to define the architecture of my code base. Okay, so let us start with the easiest part. So okay, but before starting that, my manager gave me list of requirements. Okay, so there might be a PRD. Okay, there might be a PRD or a DM or whatever that hey Vedant, I'm your manager, blah blah blah, and we have a new feature where these are the requirements. Okay, so as an engineer, okay, I'll say okay boss, I'll look into this, and when I come to this, I see that I have the Figma and I have the functional requirements. So I'll see that, okay, consider only a single project. Okay, right now we don't have scope for having multiple projects. So a Google company can have multiple projects like Google Maps, or like google.com itself, or a Google Cloud Provider. These are various projects of a single organization. So what my manager has asked, that initial version of this Jira board clone is going to have only single project. Okay, understood. Then consider boards are pre-populated. Create board feature will be added later. So what my manager is saying, that you don't have to worry about creating the various boards of this project. Consider that the data would be automatically populated for you via seeds. Okay, so I have performed the seeding for you already. You don't have to worry about creating boards right now. But in the like extra section, when we finish this particular initial version of Jira board clone, after that I am going to scale this application to contain multiple projects. It would have the ability to create boards as well. Right now we are making like initial version of Jira clone, and once we are comfortable with everything, then we will learn how we can scale this application to include multiple projects and to include multiple boards. Understood? Okay. So then we have things that we can create ticket in a board. We can view a ticket of a board. We can shuffle the tickets or rearrange the tickets in the board. Then we have to authenticate the users via Google or Google OAuth or Google Provider. We can change the theme, and we have an infinite scrolling. So these are all the functional requirements. What is the functional requirement? Functional requirements means that the basic functionalities that are expected in a given problem statement. Okay, very simple. Then my manager said that, Vedant, if you want promotion, these are the good to have things in a project. Okay, so what he's saying, that good to have, like even if these are missing, no harm, but if these things are there, then it is a good part. Okay, so we are going to cover this good to have things when we complete the basic functional requirements, and when we are left with nothing, we can take these extra features. So what are the extra features that we can have? Create a sprint board, complete the sprint, search bar, and you can have a create a project. Okay, was understood. I'll get this done. Then my manager is saying that, Vedant, there are some various non-functional requirements as well. Non-functional as in the requirements that are not related to the business logic of the product. So like whether I have to choose CSR, SSR, whether it has to be responsive design, or there has to be skeletal note or not. This is not related to the business logic. What is business logic? Business logic is this. Okay, functional requirement, that I can have a ticket, and I can shuffle the ticket, I can create a board, I can view tickets of a board or something like that. This is a business logic. What non-functional requirement basically deal with is that it deals with optimizations, it deals with like linguistic features like internationalizations and other stuffs. So non-functional requirement, he said, Vedant, you have to decide whether you have to use client-side rendering, Vedant, decide whether you have to use server-side rendering, and please make sure that it is a mobile first approach, so that we can support mobile devices, we can support big laptop screens. Then please have skeleton loadings. I don't want any blocking UI to happen. And he also said that it would be good to have. Good to have is two parts. Okay, one is good to have functional requirement, and good to have non-functional requirement. In good to have, we say that, please add instrumentations. Instrumentations means that like if you have heard, like whenever you perform a mouse click, then how would I know as the owner of the product that whether this particular user has clicked a mouse or not? So we add instrumentation events. Okay, we'll learn about that later, but in a high level, like these are event logs that the client sends to the server somewhere on the cloud, and we from that data we generate a chart where we see that, okay, this button, how many clicks it got last 7 days, which type of users were engaging with this button, whether they were free users or whether they were paid users or whatsoever. Okay, so this is a very interesting part. Obviously we are going to cover this when we finish the basic feature of the application. All right, so we have understood the requirements and everything. Now let us come back to the wireframe, and let's start with the easy parts. All right, so on the top you can see that we have a really nice navigation bar. On the navigation bar we can see logo, we have a create button, we have authentication, we have ability to change the theme. So what I have come up with that is that I will have this nav bar via config driven UI. What is a config driven UI? Config driven UI means that before understanding config driven UI, let me take an example. So let's say your app is on the production. Now, all of a sudden, product managers came that and say, hey, Dan, well, you know what? We have a basic, very big requirements that we want this logo to appear over here and this auth theme to appear over here. Can you get this done quickly for us? And I'll say, okay. Then I'll go to my code and I'll make manual changes. Okay. I will change the ordering. So auth will come over here. So logo will come over here. Okay. Then I'll change everything. Then I will create a pull request. Then it will go to testing. Then the PR will get merged. Then it will go to production, let's say after 1 week or something. So you see, there's a long process. But what advantage we have with config driven UI is that I'll say that, okay, let me create a type of JSON where the ordering, okay, where the position of the element will define its order. Okay. So if I have array of objects and each object determines whether it has what type of component it is, whether I have to render a logo component, whether I have to render a create button component, whether I have to render a authentication component or a theme change component or a simple drop down component. All right. So in that array, whatever is the first item would come over here, second would come over here, third would come over here, and fourth would come over here. Okay. So I said that, okay, I will create an array, and inside that array, there would be multiple roots. Okay. What is the significance of a root? Root signifies various parts of a single strip. So you see that this nav bar is a single strip, and it has been divided into three major sections: the left section, mid section, and the right section. There are three major sections. Okay. So my array would have 3 items, 3 roots, each depicting left, middle, and right one. The first root would contain logo. The second root would contain create button. The third root would contain 2 items, that is auth and theme. Okay, clear up till now? So this is the structure of the config. So over here I said that this is my array, and these are the properties of that object. So ID, special ID to uniquely identify, because if we are coming from a React background, so when we render array items via map, we have to provide a key. You already know that. So ID just to identify the unique root. Then component would be root. Then any styles you want to pass. Then what are the content that are going to fit inside that root. So for the first root, I have logo. For the second root, I have create. For the third root, I have auth and theme. Clear? So this content is again can contain multiple elements. That is why it is an array. Inside this array, you have similar structure. Again, ID, component, styles, then a value, appearance, and portal. What are these? So component. The component, there are 4 major components that we are supporting. One is a drop down, one is a search box, avatar, and theme. Okay. And yeah, so over here, these are the basic things we are supporting, and these are the values to be displayed. So value for this one would be logo, this one would be create, auth, and theme. Okay, these are the basic values. Then appearance is like a basic class. Based on appearance, you can tweak various stylings or what other stuffs. Then if you want to pass any extra styles, so I have named it as trigger styles. Then you have a portal. Portal basically depicts the part where you can show a content when you click on a drop down. So if you click on a drop down, for example, if I click on this menu, this is the content of this drop down, right? So this is a drop down and this is the content. So that is what this portal is saying, that okay, if I am a drop down, then what are the contents that I can show as a portal? So this is a config driven UI, and trust me, my friend, whenever now my manager or product manager says that, Vedant, can you swipe this? So what I have to do is I'll just go to this config. This config can be coming from any portal, any JSON portal, or it can be hard coded in my code base. But mostly these config drivens, they come from CMS, content management systems, where they host this JSON. And that JSON, what I'll do is I have to go to that CMS, and I say, okay, oh, so he wants this, I'll just swap the values and I click save. In moment of 2 minutes on the production, this config UI would get changed. Okay, that is the power of config driven UI. Okay, we'll implement this. It is already implemented in the demo which I have shown. And let's talk about the parts of these boards. Okay, so we have list of boards, we have this, whether this is going to be CSR or what. So let's deep dive into the major complex parts of this application. All right, so let's start with the complex components. Right now we have this side nav and the major board component. So let me talk about the major board component first. So this board, these columns are available at the URL /board/some ID. This ID is going to be dynamic in nature. So what I mean by that, this URL is, it would look something like localhost 3000 /board and /something. Since I was already working on it, so it auto suggested me that. So this is the kind of URL that we will be targeting. Okay, so what we have to do is we have to get this board ID from the URL and fetch the corresponding board details via that unique ID. This is very simple. So over here we are going to leverage the SSR capability, because on the client side, if we see the data is going to be quite complex. So we have to render first 4 columns, then we have to map tickets to each column and then render it. There can be case of paginations. So it is better that we render our component at the server side, and then on the client side we just hydrate the part. Okay, so initially we'll show a skeleton. Next.js comes with built-in support for showing a fallback UI or the loading UI. It is really very easy using the app router, and also we can use suspense as well, which we'll see when we will implement this particular part. All right, so on this part we can improve the performance by rendering this part, only this part of the application on the server. Okay, this part is going to be client, navigation is going to be on the client side. The board part is going to be rendered on the server to improve the performance. So we are going to use fetch to get the board data via server actions. Okay, so what is server actions, I haven't told yet, but this is something brand new feature of Next.js 14. Okay, and in this I can fetch data from the server without making an API call. Yes, without making an API call. So if you head over to your network tab and something, it is going to be extremely awesome, right? So that is the part over here. And the server actions are basically you don't have to write a fetch call. Okay, usually if you're coming from a React background, then you might have already been using fetch methods to call the API and get the data. But here in Next.js 14 you can directly interact with the database using server actions without making an API call, and this is, I guess, the masterpiece of Next.js 14. Okay, so what is the added advantage that the users, let's suppose you are working on a quite complex part and you have to be careful about the security. So server actions come really very handy. Why? Because if you inspect the network tab, you won't be seeing any network call. Okay, so the other person using your application, he won't be able to intercept what actually happened. Okay, so this is really very good for security purpose, and we are going to use suspense to show a skeleton loader. So if you are coming from if you have worked on React, then you might have already used suspense for showing skeleton loaders. All right. So this was about this particular board section over here in the whole. I know the information provided over here is quite small, but I really don't want to complex, because these small words, right? SSR, server actions, and suspense, they are a huge topic in themselves itself. So this was about the board component, and over here you can see that we have this section. Okay, what is this word denoting? So this arrow over here means that the ticket was moved from in review to done. And how did this happen? This will be possible by using a really great library, and this is React Beautiful DND for drag and drop. And after the drop happens, okay, we will deep dive into how this React Beautiful DND is working. But for now, let us focus on that. This after the drop, what is going to happen? So after the drop, we have to perform a server action to update the position of the ticket. Okay, so over here, if you see the ordering, so there are two tickets over here. So how do we decide which ticket has to come on the top and which has to come at the bottom? This is going to happen by use of a property we are going to attach with the ticket, that is called position. It is going to be an integer value, and we have to just sort it in the ascending order inside each column. That is it. So over here you can see that we are not only changing the position, we are also changing the board, right? So let's say this board column, sorry for that. So we are changing the board column. So this is one column, this is another column. So a ticket may be associated with in review column. This in review column might have some ID in the database, and this done column is having some another ID in database. So once we drag the ticket from one column to another, we have to perform some server actions to update the position of the ticket. We are going to see this API also once we come to the API contract part of this in the same video. So over here, I hope this part is clear, this like how we are going to render the boards. And if you really don't understand this LLD part, if it is bouncing off your heads, then I'll suggest is that you first start with the development part of the video, okay, where you set up the project, you understand each and every part, and then you come to this LLD part at the very last, so that whatever I'm speaking right now, you can understand it better. But I really hope that shouldn't be the case. If you are little bit familiar with React, then this may sound really very easy to you. Okay, but if not, then you can try out the way which I suggested just now. Okay, so this part is going to be server rendered, and we have already seen that we are going to utilize React Beautiful DND library, which we are going to explore when we start with development. And after the drag and drop of the ticket, we are going to make an API, not make an API call, basically call a server action to update the ticket status and positioning. Okay, so this is the part. And what about this part? Okay, list of boards. This is a vertical strip called a side nav. So this side nav is going to be present just like navigation bar, irrespective of the page. What I mean by that is this nav bar is going to stay on the top on every page of our application. So will this list of board is also going to be there. Okay, so one thing we can say that, okay, Vedant, let's make this list of board completely client side. Okay, initially when I was working on this was a client side application, but then I realized that I can make some part of it as a client and I can make some part of it as a server rendered component. Okay, so this list of board is going to be a hybrid component, mix of both CSR and SSR. So it is going to give a very great performance. Okay, and the only condition with this is that it is only available if the user is logged in, and if you are not authenticated, then this side nav is not going to be present. Okay, that is why I initially planned to have this component completely server rendered, but due to use of hooks, use of authentication hooks basically from Next.js, it was really very tough to make this a server side component because hooks are not present in the server side components. Okay, so I had to convert some part of the code into server and some part of code into a client side application. Okay, so that was the basic idea of the list of boards, and we have to fetch the board via server actions. This is pretty much known. We'll try to utilize server actions as much as possible without making use of fetch or making APIs. Okay, so this was pretty much about the architecture of the overall component. Okay, I hope I didn't miss anything. Yeah, so this client side part is almost done. Okay, for the module 3 module 4 parts. Now there are still certain parts which are not covered in this initial LLD. Is that whenever you click on this create button, a dialog will open and it will ask for the details to create a ticket. I will cover this LLD separately, or I may attach it in the same lecture after as as a continuation. But there are some pending features which we will work in the same course only. Okay, so I'll make sure these features are in the same course only. I'll add these videos, but let me tell you what are the features that we are going to work in the future. So when you click on this create button, a dialog will be open and it will ask for the details for the ticket, what are the attachments, who are you going to assign this, and whatsoever. And then when you hit it, the ticket is going to appear over here somewhere. Okay, and if you click on the ticket over here, so again a modal will open listing out all the details of the ticket. Okay, so these are the two features that I'm not covering in the initial phases of this application. Once we are done with this whole setup, then I'll jump on to this next features called create and view tickets. All right, I hope that is clear to you. Now coming back to this part. Okay, so we are done with this client architecture, functional requirements and framework, DB setup and all. So let's talk about database schemas. Okay, what are the various type of schemas that we are going to have in this application? Since this is a full stack framework, so I expect that we have to work on backend as well. So we are not going to be just like an average front-end developer. We are also going to perform backend, and I'm going to teach you each and everything, how to write schemas, relations and everything. Okay, so this is the DB schema. I know it is sounding little complex with all those lines and all, but once I start explaining, things are eventually going to make sense, and it is really very simple. Okay, so first of all, let us just start with this part where I have a board type. So we can have various types of board. This will come handy when we'll implement filters. Okay, and there can be 4 status of a ticket. It can be to do, it can be in review, it can be in progress, or it can be marked as done. Okay, these are the basic 4 status of a ticket, and these are also going to be the number of columns that a board can has, right? So talking about this, I hope you got the point where I said that this is also going to be the number of board columns that it is going to have. So right now a ticket can have 4 status: to do, in progress, in review and done, and each status is represented by a vertical column. Okay, if ticket is in this particular column, it has to be in to do. If this ticket is in this particular column, it has to be in progress. Okay, so the number of status is going to be number of board columns. That is great. So let us start with very high level components, and then we'll break down individual smaller parts. At high level we have this complete board. Okay, this complete board. So what are the various? Okay, so this is the board table over here, and these are all the fields that we are going to need. Okay, so I have tried to name this schema as close to the schema that we are going to write in the actual applications, so that when you come back to this particular part, you understand it better. Okay, so over here we have this ID. Okay, we have this ID, unique board ID. So there can be many boards, as I have told. So this is going to be a unique ID of each board. Then what is the type? So I have written board type, and this board type, if you follow the line, if you follow the line, it is taking you to this board type. Okay, you just have to follow these lines. This is a red line, so I am following this line and it is taking me to board type. So type can be either a sprint or a Kanban. Okay, and this is important for concept for you to understand enums. Okay, I'm also going to explain a TypeScript here as well. So if you don't know about enums, like it is like declaring constants. Okay, so there can be various constants, right? So think of constant as for example, like if you are running a video, then what are the various status of a video? It can be loading, it can be playing, it can be pause, it can be restarted, something like that, right? So these if you work on plain vanilla JavaScript, you define const. Okay, or you declare an object, the const player state equals to object, and inside you write all these values. Similar in TypeScript, you can use enums. Okay, so this is a really very great approach. I'll tell you in depth when we will implement this in actual. So right now, just understand that these enums are corresponding to constants. Okay, so we have this board type. Then board can have a title, it can have some description, and a question mark over here indicates that this is a non-mandatory field. So it can be either filled in the database, or it can be left as null or undefined or empty string whatsoever. Okay, so this question mark is that it is not for me, right? I'm not confused. Okay, this is for defining telling the contract that hey, this description field is optional, it is not mandatory to be filled whenever a row is created. Okay, so now coming back to this start time is basically whenever a sprint would end. So let's say I created a board for this particular project, and this particular board can start at today, and it can end at after 7 days or 14 days. Okay, so that is what it is there. So when this board was created, when the board is going to end, so start date and end date, and what are the various columns it is having. Okay, so this is where the concept of relations comes into the picture. I'm going to explain these terms when we are actually implementing it, but for now at high level, just try to understand that over here. So you can see that this board has actually 4 board columns. Okay, to do, in review, in progress, and done. Okay, 4 board columns. So over here, okay, this is a relational field saying that this particular board can have array of board columns. Okay, this is an array. Okay, this is an array like this. Okay, so this can have array of columns, array of board columns. So what is board column? Board column, if you follow the red line, it is merging in board column table. This is another table. Okay, so array of board columns can reside in the columns. This is really very interesting. Okay, this is relations. I am saying that this particular board can have array of another tables, right? The array of another tables. This is really very good thing. Okay, and this tickets, it can have many tickets, right? This board can have many tickets. So I say array of board tickets. Now what is board tickets? Board tickets is again, okay, just follow the lines. This is another table. Okay, and I'm saying that it can have array of tickets. Okay, so this was a relational field, and I'll tell you in detail why this array concept come in SQL and how this is working once we write the schema. Okay, then you'll understand it better. So this was the board. Okay, so I have all the necessary things. So in the board I can have columns and I can have tickets, that is clearly represented here. Now if we talk about columns, if we talk about board columns, there can be unique ID. Then a board column has a position. Okay, so if there are 4 columns and I am ordering them like to do, in progress, in review, done, then there has to be certain order in which they are going to be represented. So that is going to be represented by position. Okay, we are going to sort on the based of position. Clear? Then we have a label. Label is like ticket status. So what is ticket status? Ticket status is saying that it can be either to do, in progress, in review, or done. Okay, clear? Then this board column can have many tickets. Okay, because over here you can see that this column can have many tickets. All right, so we are having a relational field saying that tickets, this would be array of board tickets. We have already seen what a board ticket is. So if we follow this particular line, and it is merging over here, so board ticket, array of board tickets. Now we have another field called as board. What is board over here? So a board column is associated with a board. So a column has to be a part of a board. Okay, a column cannot exist outside of a board. Okay, this is very tightly coupled relation. That is why we are using SQL. So we have this board. Okay, this board reference over here to board, follow this white line, and then we have a foreign key. Okay, we have a foreign key. So this board ID, if you follow this particular line over here, let me just swap the arrow. Yeah, oops. Yeah, so if you follow this blue line, this is taking you to the ID. Okay, to the ID of the board. So this is a foreign key. Okay, using foreign key we can determine that this particular board column is part of which particular board. Okay, and this board is just for the reference. Okay, this is just for reference. Why do we have even added? This will get clear when we write the schema. Okay, so we have this board. Now coming back to board ticket. Okay, let's go to board ticket. This is having many fields. Oh my god. So a board ticket can have ID, it can have a title, it can have a description, then it can be assigned user. Okay, who is going to perform the task of the ticket. So this user is just a relational field. Okay, this is just a relational field over here pointing to the user table, but the actual foreign key is assigned to. This is what we will be using when we are querying our DB. Okay, so assigned user will never come when you perform any query on the table. This particular row will not exist in when you fetch the results. Okay, then why is it here? This particular field, my friend, is going to come handy when we are going to use Prisma. Prisma would be our ORM. If you don't know about ORM, no worries. But when we are going to use Prisma, when we are going to create schemas, and when we run Prisma Studio on top of that, you can just click on this particular row or the column, and it is directly going to show which particular user we have referenced over here. Okay, this is very powerful thing. Okay, so one thing to note that these relational fields are never. So what do you think? This columns would come as it is? No, right? This is not. So coming back to this is the relational field only. Okay, this is only a relational field. Okay, so this is not going to come whenever you are querying. This is only for the visual purpose when you are going to run Prisma Studio. Okay, I hope that is clear. If it is not, then just you can keep this words in mind, and when we will implement it and when we will actually see in the Prisma Studio, then you will understand it. All right. So then similarly we have reported user who has created a ticket. Then this ticket is going to be part of a board column. Then we have a board column relational column. Sorry. Then we have a foreign key. Okay, foreign key, you can just follow this pinkish line, and it is going to take you to the field. Okay, so it is really very easy, right? You just have to follow the lines. And then you have a status. It is going to be status ticket. Then we have a board. Okay, so board is stating that which part of the board this ticket is. And why do we need board when we already know board column? When we already know this is associated with board column, then why do we need board? Think about that, right? So we need board, right? Because a ticket has to be part of a board also, right? Not just a column. This is just extra validation. Okay, so that is why it is really very important. And trust me, when we are going to query, so when I'll show you this API, right? Whenever I will talk about the API contracts over here, there would be one very crucial information or step that I have taken to ease our usage of infinite APIs. Okay, that I'll not disclose every magic in a single go. Okay, you have to wait for the right time. Okay, so when we will discuss in the same video, when we will discuss this API, then I'll talk about why did we need it, why did we need this board thing. Okay, then we have this comments, array of comments. Then we have, what is comments? Comments is this particular table. Okay, so we have so each ticket users can add comments, right? The discussion that is going on, so they have this thing over here. Then you have story points, then the position for the ordering. Okay, then simple thing, comments, it is having nothing fancy. But yeah, it is a complex part. Why? Because this description which you see, right? The description can have codes, the description can have images, it can have videos, it can have simple text, right? So this is crucial part. Then how we are going to deal with? We are going to deal this with help of a really good editor called as Tiny MCE editor. I'll disclose that when we will implement our comment section component. It is really very cool thing, and this is the part where file upload handling will come into the play. Then we will render the code, then Prism.js, then syntax highlighting, and many other stuff, right? So you have to be really very careful, although it is just a simple column with some strings, but populating that string is really very tough. Okay, it is not that easy. Then who was the commenter? Written by, created at, board ticket. Okay, so a comment is associated with a ticket, so this is a foreign key over here. Then simple users, ID, name, email, is email verified. Okay, email verified is date, time. I think this has to be boolean, right? Email verified, and then we have a image src. Okay, URL. So this was the DB. I covered it fast because I really didn't want it to get into the complexities right now, because if you get into the complexity right now, you won't be able to understand it unless you visually see those, right? So this was the DB schema that we have finalized. So we are done with component architecture, framework deciding, DB decided. Then we talked about config driven UI, SSRs, CSRs. Okay, how we are going to choose. We talked about the beautiful D&D library. Okay, now let's talk about some two major APIs. Okay, we'll not keep a lot of APIs in a single video. We'll talk about two major APIs. Okay, so the first API is the main one, which is the fetch board API. Okay, which screen I am talking about? I am talking about this particular screen. Okay, when you fetch these columns, these tickets, okay, this is the fetch board API. Or why I'm saying API, because eventually this would be a server actions, but just for sake of understanding, I'm calling this as a API. Okay, first we can create a API also. Okay, I will tell you both steps. First, I'll create a generic API. We will test it on Postman. Then I'll tell you how to convert that into a server action. Okay, so this what is the endpoint going to look like? So first of all, it is going to be a get method. So when we are fetching something, so it is going to be a get method. So endpoint would be /API/board/fetch, then a question mark, and these are query params. So whenever you pass anything in the URLs by a question mark and then and, so those things are called query params. Okay, so what are we passing in the query params? We are saying that what is the board ID I want to fetch. Okay, this is the board ID, some random string. Then skip and take. Now what is this? Okay, what is this? Why is it so complex? See, if you remember the functional requirement, there was a part where I stated that there has to be a infinite scrolling. Okay, infinite scrolling is going to be there. So this, it is a kind of a pagination only. So skip and take, what it says. So skip says that number of tickets to skip for the pagination. So for the first call, you don't have to skip anything. Okay, for the first pagination call, you fetched 10 tickets without skipping anything. For the second pagination call, so you have to skip 10 results and fetch the next 10 results. Okay, for this third pagination call, you have to skip 20 tickets and you have to fetch the next 10 tickets. That is how it is working. Okay, so skip would be first 0, then 10, then 20, 30, 40 and so on. And take is what? Take is like how many tickets you want to fetch in a single API request. Simple. Okay, really very simple. Okay, I'm not using very high-fi words. I'm just making sure that this course is understood to everyone. Okay, very easy. Skip something, take something. Very simple. Okay, now what is the response going to be look like? Okay, so we get a big object. Okay, this I got from the actual data. Okay, actual mock response. And in the data you have the board. So this board is going to contain details about the board. Okay, like board title, board type, when this was created, when this is going to end, description, board ID. Okay, all the UI stuff related to boards. Now we will fetch the columns separately. Okay, so we have fetched all the columns. This is the array. So ID, position, what is the label, what is the board ID. I think I am yeah, so board ID is what? Board ID is like this only. Okay, this only. Though this got, I think, fetched while writing the queries. We can even omit this. Okay, I'll tell you how. So ID is what? ID of the board column. What is the label? What is the position? So we get 0, 1, 2, 3, 4 items we got from the board columns. Then we separately fetch the board tickets. Okay, so now over here, if you see these tickets, okay, they right now all the tickets are fetched irrespective of the column. So if you see this board column ID, right, this board column ID is over here. Ideally you would have expected me to have one field over here called tickets, an array, and inside that array I must have pasted all the tickets, but I did not do that. Why? Okay, I give you 2 minutes or 1 minute, how much, whatever time you want to take. Just think, why did we do this? Okay, so pause this video, take your time and think, and then resume it. So let me reveal this for you. So if you remember, we have this pagination, right? So in the board ticket request, okay, in the board ticket request only, if we add pagination to board tickets only, right? So so think of it in a way that there are 3 queries in this function, in this API call. One query to fetch the board, one query to fetch the columns, another query to fetch the tickets. So where do we exactly need pagination? We need pagination in board? No. We need in board columns? No. We need pagination only on the tickets. Okay, so whenever we are hitting the query to fetch the tickets of this board, not related to column. So whenever I am fetching tickets, I am fetching tickets of a board. That is why over here in the board ticket, I had this board ID as a foreign key. So what is a board ID currently for this board? This board ID is this, right? CLRUT something. So I will fetch all the tickets that have this board ID. Okay, and then I will introduce a pagination on that. Okay, on that. On this, I will include skip and I will include take on that query itself. Okay, I will show you how. I will not show you right now exactly how we introduce skip and take, but that is the main purpose. So whenever you are making any pagination call, these board tickets, my friend, is going to be generated. Nothing is going to change in the board columns or board. To make infinite scrolling achievable, it is really very important to fetch the tickets separately. And then on the client, what I mean by client, so I will use client for front end, okay, and server for backend. Okay, so on the client, we will directly map these tickets to boards using simple loops. Okay, nothing rocket science over there. So this is the major API. And what is a ticket? What we are getting inside tickets? So we get ID, title, description, assigned to, reported by, board column ID, status, board ID, story points, and position. These stuffs only. Okay. So this was the major API, fetch boards. Then we have another major API, that is to move the ticket. When I say move, it means not that move. Okay, not that lotion wala thing. Move like whenever we drag and drop on the ticket. So over here, if you see, we what are the things we have to pass? Oh, I think I forgot to update the description. Just give me 1 second. So over here, this was the endpoint /API /ticket /move. This is going to be a post call, and in this we are going to pass 3 data as a payload. One is the ticket ID. So ticket ID is ticket that you want to move, and then we have the board ID. So board ID is the target board where you want to move the ticket. It can be same, right? If you are moving the ticket inside the same board, then the board ID is going to be same. Otherwise, there can be, this gives us ability to move ticket from one board to another also. Okay, and then this is the board column. This is going to be the target column. So what are the board columns over here? These are these things. So over here you see that this is one column, this is another column. So done would be, if we are performing drag and drop over here, then done is our target board column, and we are performing this operation on the same board. Okay, so that is why we have this board ID. Now once this operation is successful, you will get in response this particular data, the ticket information only. Okay, nothing fancy. So my friend, this was the LLD. Okay, this was the LLD of the basic like initial version of the JIRA board clone, and we are going to make further improvements on this LLD when we introduce new features. So I really hope that this was a really good insight on the LLD of the application. We understood the component parts, we understood the requirements, we understood even the high level aspect on deciding the framework and database, and we also deep dive on the API contracts as well. Okay, so what happens in the company is that initially, that once you prepare all this, all these things are generally reviewed by some senior of your company. So let's say if I am SD2, then this document would be reviewed by senior SD, staff level, or principal engineers, and sometimes even architects also get involved. Okay, so that is why if you want to progress from SD1 to SD2, then try to pick works. Okay, try to pick work in a company which have these LLDs related stuffs. Okay, where you can create these nice slides and you can think on what to use what. Okay, what to use, which key, which values, what is the data type, what would be the component type, server rendering, and mix and match of everything. So once you get comfortable with this, your system design skills will eventually improve. Then you can easily walk on the ladders of higher level roles, be it SD2, senior, principal, architect. That is how things are done in big tech companies. Okay, So I really hope you got lot of knowledge in this particular lecture, and I'll see you guys in the next one.